My name's Nick Holliman, and I'm going to talk to you today about some work we've been doing on human-machine teaming, bringing algorithms and humans together to make decisions. So one of the questions Turing posed was the Turing test. Can we distinguish between an AI and a human being? It's an interesting technical test, but actually I'm much more interested in when can an AI machine become a trustworthy colleague? When can we work with AI? And how easy is it to work with AI systems in the same way we work with humans? This is an exercise we've set for our students, and what we're interested in here is assessing this and providing feedback to the students. And what I was interested in was, can we improve the way the marking and feedback process is done by using algorithmic deep learning and other machine vision methods? So the exercise here is to visualize the outbreak of an infectious disease across Manchester. It's a DSTL PhD project we did a few years ago, where we're given 1,000 simulation outputs, and each cell in the simulation has a certain level of impact or infection and a level of certainty associated with that. And we're interested in finding the most certain, highest impact areas so that commanders can send medical aid to the right areas of the city. In visualization terms, we're interested in assessing this as different ways as a high quality visualization. Does it meet basic visualization quality issues? We can't go through all of them, but for example, are the colors used color vision deficiency safe? Is the layout in line with Gestalt principles or not? So the human machine team here is a combination of systems put together that do a machine assessment of the work and my own marking processes. So the student submission comes in at the top, and the first thing that is done is it's fed through a series of machine analysis tools, edge congestion, saliency prediction. So we've used in the saliency prediction various algorithms, and a set of color vision metrics, both quite objective ones and also some subjective ones on color preference and color aesthetics as well. Once those processes report results, that numerical and visual feedback is fed to a database to store for comparison against future work, and also into a machine feedback part of the feedback, which will eventually go back to students. This then feeds into my human marking. So this is the point where we start to do a teaming with the machine, and it gives us some quite objective metrics to start to assess the subjective quality of the visualization. So I've got to assess all the same things and mark them, but I've got some evidence now that I didn't have previously. So important issues I want to pick up though, trust and trustworthiness. How do we make these combined machine and human decisions safe? So first thing we do is we be open following the OSR recommendations after the A-level results issues. We certainly show the students the AI assessment methods during the course. We're then quite rigorous in testing them, so we test them on non-course material as well as course material. But you'll see here the distribution of the marks. The top distribution is the original marking before we used the machine assessment support, and the bottom two are distributions in later years when we're using the human-machine teaming. So finally, does this meet need and provide value? It adds evidence to the marking feedback process. So personally, I think it does add value to my marking. The students have liked it. I've had messages from the students saying they like the feedback, as did the external examiners. And it has this year, because I've not been developing the system this year, reduced the time doing the marking and producing the feedback. We also have to consider ethics issues, privacy and regulatory frameworks. The aim of this work is not to automatically grade the student work, so we're not doing what the A-level algorithms are doing, but it is to produce this human-machine team and to let the machine take on the work that is harder for humans to do, and let the humans do the value judgments, to make the informed decisions and to apply the common sense to come to the marking and final written feedback for the students. I suspect that reading through Daniel Kahneman's work this year, a key benefit of this may be to help us over time reduce noise. So because we have to run this type of study through ethics approval, we need students' permission to use their data, so it necessarily limits some of the things that we can talk about. And it tends to be the better performing students who give permission as well. So we can't do rigorous controlled studies in the same way that the health scientists cannot. I want to make a note on the EU AI regulatory framework, and I think we're going to have some interesting challenges ahead if the UK adopts the EU AI regulatory framework in its entirety. Thank you for listening. Thanks also to all my students.